So before I hand the presentation over to Mike, I just take a couple minutes to provide an overview of what we're going to be covering today. So to start, Dassault Systems is made up of 12 different brands that serves 11 different industries. And each of these brands create solutions that are connected through the 3DEXPERIENCE platform. And we launched the 3DEXPERIENCE platform in 2012 to create a unified platform or business system for our customers so that they have a single source of truth for their data. And Mike will get into this a little bit in his presentation, that then can be shared in real time, to the right people. And the brand we're going to talk about today is the Delmia brand. And when we discuss the Delmia brand, it really covers, many areas of manufacturing, from manufacturing planning, facility layout, operational and supply chain optimization, and digital manufacturing. And today, we're going to really focus on factory layout and optimization, and then the digital manufacturing with robotics and subtractive and additive manufacturing. And Mike, hopefully I don't steal any thunder from your slides. I stole this one from you. But Mike's going to cover some of the challenges today of what we see in the industry right now, and some of the things that customers are telling us, and then discuss some of the solutions that we have for factory automation, manufacturing collaboration, and fabrication and machining. But before we do that, I am going to post a question. I got a poll here for everybody. Let me see if I can pull it up here. Let me launch this. And 2 questions. All right, Mike, how do I show this on the screen? Is it showing for everybody?
Yep, it's showing.
Oh, great. So the first question is, what is the biggest barrier hindering the implementation of smart manufacturing in your organization? Lack of budget, resistance to change, skills gap, no, you don't have any barriers. And the second is, where's your company on automation journey? Are you currently using robots, additive manufacturing, factory simulation, IoT? Looks like we're getting some pretty good feedback now from everybody. We'll give it another 10, 15 seconds here for everybody to give feedback. Looks like the polls are slowing down a little bit. We appreciate all the feedback from everybody. Mike, you think we're good in the poll?
Yeah, I think we're pretty good. It looks like most people have filled out. I think we're almost 3/4 of people responded. That's pretty awesome.
That's awesome. All right, I'm going to end the poll. And with that, again, we appreciate everybody joining the webinar today, and I'm going to pass it over to Mike to get into some of the good stuff.
Yeah, so one of the things here I want to do is we can share some of the results. Let's see if those pop up here quick.
Awesome.
They show up
I'm
on your...
going to stop sharing my camera too for bandwidth, just in case.
Okay. So if we look at the results there, it's pretty interesting, Dean. It's pretty even across the board at the top for skills gap, resistance to change, lack of budget, right?
Yep.
That's a lot of what we've seen worldwide, not just in one specific region. And then if we're looking at company on the automation journey, it looks like there's about 60% that is either thinking about it or just getting started, which is also a lot of what we see. So thank you everybody for sharing on that. That's pretty interesting.
Yes, thanks so much.
So with that, let's see if I can figure out some magic here today. It's my second day using a computer, so let's see what we get to come up here. Just like Dean, I'm going to save a little bit of bandwidth without doing video. Also, as we were talking before it started, I'm a little more built for radio than television. So to not scare anyone off and focus on what we're going to talk about today, we'll just keep the slides up in front of everyone. So to talk about automation, talk about Industry 4.0, digital transformation, pick a buzzword, doesn't really matter. They all fit in the same bucket. To figure out where you're going, you also have to know where you're at. And so what we're going to do is we're going to spend a little bit of time talking about where we're at, and then we'll talk about some possible ways that we have seen and helped companies integrate and go down a journey of digital transformation, Industry 4.0, smart manufacturing. Again, all the same thing, continuous improvement. So one of the things that was in the poll that I think everybody is faced with, it doesn't matter what industry you're in, is labor challenges. It's an interesting phenomenon for lots of different reasons. But in manufacturing, a lot of what gets talked about today is there's a couple things that are actually happening. One is, for a very long time in manufacturing, we haven't always been seen in the best light, as far as a job to work or do, especially here in the US compared to other countries. And because of that, a lot of people aren't growing up saying, boy, I really want to become a machinist, or I want to do something, cool in a factory. Most people are trying to go do other things because they don't understand that factories over the last 20, 25 years have become really high-tech environments that have really well-paying jobs and a good future. So part of the challenge we have is image, which then leads to labor challenges, right? So we have a retiring generation or an aging generation that is in manufacturing, goes through these processes. And on the other side, we have people that don't even really know what manufacturing is. So I read a stat last night that was very interesting, that by 2030, 1 out of 6 people on the planet will be over 60 years old. And so when we start talking about labor challenges and things like that, I mean, that's a pretty big statistic, 1 in 6 over 60. That means that there is a huge opportunity in manufacturing, but part of the challenge we have is, how do we fit the jobs for the next generation of person? And part of that comes to different ways of thinking, more flexible jobs, doing high tech, as an avenue, getting into robotics and automation and PLCs and controls, and really showcasing the value of manufacturing being high tech versus something that's shown in a movie like a dirty, dingy cave. The next thing that comes into an interesting challenge is globalization and supply chain. This really hit a few years ago. It's unfortunately hasn't fully went away yet. May never go away. Part of everybody being connected and everyone working together means that if there are changes or things or issues that happen in different parts of the world, it affects the entire supply chain network. One of the things that becomes more interesting too is, back when I used to work in the quote unquote real world, we could quote a truckload of steel for a month and it would be good for a month. Today, that same truckload quote is good for about 24 hours. So as we're quoting and filling out orders and trying to gain more business, we have to use more data to understand whether we're making money in real time, because we can't quote something at a 10% margin with the risk that the material is going to go up 30%, right? Like, we have to have a give and take in that. So when we look at supply chain and we look at demand and we look at issues, there is a big driver in that. And a lot of the big drivers are based on using data and analytics to be able to better navigate the course as things change over time. Sustainability is also a big one. As the world changes their practices and what they do globally, from being sustainable to, am I making the part the best way without creating a bunch of scrap, that maybe I can or cannot recycle, to how companies are going to build components in the future. That all sort of fits in that sustainability bucket. And one of the stories that I like to talk about and share to get people thinking differently is, if you think about aftermarket truck bodies or aftermarket components that go on vehicles today, even running boards or steps or, skid plates as an example. Today, most of those things are designed in a way that I can just go drill holes in the frame of a given vehicle or pickup truck, right? And then I can put some bolts through it and I can mount it, and away I go. Well, in the future, if more and more vehicles become electric, oftentimes the batteries are put where the frame once was open. So you're not going to be able to go through and just drill a hole in the side of the battery box, because 480 volts will hurt all the way until you're no longer with us. You have to think of new ways to be able to mount those. On top of that, generally electric vehicles are heavier because of the amount of batteries they carry. So the way that you used to build those accessories yesterday are going to have to be very different tomorrow, because you can't just make them out of galvanneal, as an example, and just create a 2,000-pound box on there, because you may overload the axles and the requirements that go with it, because there's so much more weight being put into those vehicles. So when we talk about sustainability, it sort of covers a big wide array, but part of the challenge that goes into that too is we have to come up with new ways to manufacture, new ways to think, new ways to design, new ways to stay competitive. And that leads us into the next area, which is competitive advantage. One of the things that has also changed in the world today is it used to be if you were a leader in your industry, you had the buying power and the capability to put yourself in a position to be about 18 to 24 months ahead of your competition, right? Because you could buy companies that are a little bit on the slower edge, you could buy them up easily, you could adopt them, bring them into your portfolio, and you could shrink the pool the bigger you are. The reason that that worked was in the past, output was solely based on manpower or person power, meaning that if I went and bought a bunch of other companies and bought their logos and brought them in, I could add more people to just produce more goods and stay ahead of my competition. When you look at how the world works today, the supply chain challenges, things of that nature that go into it, sustainability, labor pool, the competitive edge is now changing to where a startup company with VC backing or investor backing can use tools starting from scratch, be innovative enough to get started and compete within a 12-month window, which means the 18 to 24 months that large companies used to have is starting to shrink. Because if I had 10 small competitors now start to come towards what I'm doing, but they're more flexible and agile and come up with new ways of manufacturing, they could cut into my business rather quickly. And so what we see is in a lot of scenarios, the startup, the people in their garages, building home shops, things like that, are able to have a bigger impact than they ever have in history because of those factors to be able to navigate more quickly. So what are some of the challenges that we run into? Well, some of the challenges we run into are the result of human nature. Most people that go out and start a company to build widgets or design the next rocket or do whatever they're going to do, they have an idea and they have a process, and nobody ever sits around and thinks, boy, I can't wait to get this thing off the ground so I can hire 50 people that I now have to spend the rest of my life managing. They get into the process thinking about, okay, I have this thing, I can contribute to my community, my society, I can make the world better. Ultimately, I can make some money, right, to make my life better. And what happens is a small company transforms into a bigger company over time. And it's sort of organically grows in a method that just develops silos. And the reason it develops silos is as you get bigger, you need to hire in a person. And a lot of companies get stuck in this. Well, I'm going to hire a person. This person knows XYZ software, so I'm just going to buy the software so I don't have to train them. And we start just adding a bunch of random products. And because we're so busy trying to become the next bigger company, what we do is we create all kinds of silos of point solutions and products and things of that nature that really then put us in a silo to create barriers. Engineering does engineering stuff because they have this random software that they bought, and they bought it for a person that's no longer even there. And it's in that no longer there is actually speeding up as well, because the average length of an employment these days is about 3 years on average. So if you look at people now, companies buying software for a person, they leave in 3 years, I'm still stuck with the software. It just builds departments out organically because that's just what we do. Well, that person has the software, so I got to go to them to get that solved. And when you look at Industry 4.0 and you look at digital transformation, there's a couple step process, and we're partway through the first process. So when we look at digital transformation, the first step is to back this video up here, is to take all the data on the left, give it just a second to start, and create it digital, which means most companies have a server that sits somewhere, and in that server, they go through and they parse data, right? They take their Excel spreadsheets, their emails, their drawings, their CAD models, whatever it's going to be, inspection reports, all their ISO 9001 documents, and they digitize them. And in the early days, everybody would take them and scan them, put them in a server, and then that's step one, right? We created a manual process, and we duplicated it in the digital world, but it all resides on a server somewhere. And so we did the first hurdle, but still, if I want to open an engineering document, I got to go to someone in engineering to be able to open it in the software they have, because that's just how it works. Or my favorite phrase, that's how we've always done it. So when we start talking about Industry 4.0, we start talking about manufacturing, we start talking about things like that, what we're really talking about is taking the data, putting it in a centralized platform that treats the documents as native, so people can open up what they need when they need it without having to go to other groups. And when we're talking about documents, we're not just talking about CAD, we're not just talking about CAM, we're talking about all the documents that are needed. How can people pull the information they need? A good example is, we'll talk about engineering for a second. Engineers go and they create an assembly and they create an engineering bill of material. These are all the things that we have to do to ship a finished product, right? Well, that's great, and it's automatic for the engineer, but then that document generally gets exported to an Excel spreadsheet or a Word document or however. And then a manufacturing engineer or a process planner goes in, they take that neutral format now, that's in Excel as an example, and they create the bill of manufacture, because how I'm engineering it and what the finished product is does not match how I'm going to manufacture that. Maybe it has to go out for anodizing and then come back and be finished machine, or powder coated and finished machine, or heat treated and finished machine. Doesn't really matter. But there's a whole bunch of other steps that go in there that's captured in manufacturing. And then once it comes back from the manufacturing side, if it's a product I create that then I service, then I have to create a bill of material for service, because how it's going to be serviced and ordered in the future is different than how engineering did it, which is different than how manufacturing did it. And that little process there sounds complex, but people do it every day. And the way that they do it is they take what engineering did automatic for engineering, and then they create a manual process downstream. When we're talking about unified platforms and digital transformation, Industry 4.0, smart manufacturing, pick a title, what we're talking about is, if engineering creates their stuff, the manufacturing engineer should just be able to leverage it and add their bits of information to it. And then people that do service should be able to take what both engineering and manufacturing engineering did and add their flavor to it. And all of that coexists in one space that's all linked and tied together. So if there is an engineering change or a recall or whatever it's going to be, I can now track the update across all those processes because they're all connected. A change action happens as a change action across an entire set of operations and rules. So we're talking about platforms and we're talking about digitizing. What we're talking about is connecting people, process, and ideas to their data, because data is the byproduct of the process we create. Again, go back to the beginning. Somebody did not get into business and say, boy, I can't wait to manage terabytes of data. It's not what they got into it for. What they got into it for was to make a product that helped their community, helped their ecosystem, made a little bit of money, made the community better. Along the way, we created processes as humans that created X amount of data, but we didn't think about how that data would be managed. And when you look at manufacturing today, because of the high-tech nature of manufacturing, we're becoming very quickly a data-based organization, meaning that the data drives every decision we do. And the reason for that goes back to labor shortages, skills gap, supply chain issues. I can't just willy-nilly quote and be like, oh yeah, Dean's been quoting for 30 years. We just trust his gut. You can't do that today, because Dean's gut may not be as sharp as the market changes that happen when we order material, right? So when you hear me talk about the platform, what we're talking about is connecting data and information to people through the process with ideas, but the data is the byproduct of what we create.
Yeah, I'm pretty sharp still, Mike. I'm pretty good at it.
Yeah, I know you're pretty good at it, but you know, we're getting a little bit older, and if you had a spicy burrito last night, you might be feeling a little extra spunky today, right? Take a quarter off that. So to sort of go back and cover a little bit and to tie this all back together to what Dean started with. And Dean did not steal my thunder. There are no thunders to steal in this discussion. But when we start talking about it, what we've identified globally by doing tons of analytics and research and how people are doing digital transformation, it really comes down to most companies start in one of three buckets. They start in the bucket of factory automation, which we're going to talk about a little bit here today, or they improve collaboration. How well do they communicate and share ideas? Or in some instances, they improve their machining and fabrication process. And that could mean I put in an index machine or I put in a Swiss machine, and now I need better tools to make that product more efficient, right? I need to be able to take advantage of all of the capabilities of what I put in. So depending upon where you're at in your transformation journey, there's a couple different avenues. Now, keep in mind, as you go further into the journey, there's an overlap that happens because that's just how you grow when you digitize. But not everybody starts at the same spot. So if we take collaboration as an example, we did an independent study a year ago now, almost 2 years ago, and we pulled a whole bunch of random manufacturers worldwide, and we asked a simple question: how well do you communicate and collaborate internally? We did not define what that was. We just asked how well they did. And then we asked different levels of the organization the same question as it relates to what they do within the company. And what was interesting about that is we then tied it to business, and we asked them whether their business was growing or shrinking or staying the same. And the correlation that came across loud and clear was companies that communicate and collaborate effectively, from the CEO to the janitor, are growing their business by up to 20% every year. The companies that are dysfunctional, from the CEO to the janitor, meaning they don't communicate, they don't collaborate, they're not on the same page, the janitor doesn't know what the vision of why they're losing up to 20% of their customers every year. So what that means is, if you're not finding methods to communicate and collaborate effectively, you're risking not being around in the next 5 years, because you can't continue to lose 20% of your customers every year and be around after year 5, right? It's just not going to happen. So that is one example of collaboration, right? Just getting everyone on the same page, using the same tools, talking in the same language. Like I said, we're here to talk about factory automation today, because one of the big areas of improvement is one of two methods. I have a factory that I need to make more efficient, because if it was more efficient, I could get more business and then grow. Or phase 2, we're going to buy land and we are going to move and build a brand new building. And not only do we need to make sure that everything we have today fits in the new building, but this is the perfect time for us to restructure what we do in a way that will make us successful for the next 10, 15, 20 years. Oftentimes, restructuring is then followed by automation. Am I putting in machines with bar feeders? That's a sample of automation. Am I doing robot programming or robotics? Programming is a side note of robotics, but let's say we're going to put in robotics. We're going to put in conveyor systems. We're going to put in an automated paint powder coat booth with a 5-minute changeover. Like, those are all levels and versions of automation, but oftentimes people start with, what do we have today and how can we improve that digitally? So with that, we're going to go through a couple videos and examples of robot programming and simulation. And just to give you an idea of, when we're talking about factory automation, the lens that we see it through and what most customers are looking at today. And it's worldwide when we're talking about it. So it's a pretty big sample size of things that we're looking at. Okay, and Dean, I'm going to ask you, when I start playing these, let me know if they are chunky at all, or if they're coming through okay, because that way I'll speed them up or slow them down.
All right, sounds good.
Okay, so if we look at layouts for factories. Most people today are in the realm of cardboard aided design, duct tape lines, drawing on the floor with chalk, or having some version of 2D CAD. And so when we start talking about that flow and sim, when we start talking about this, the first thing that jumps out right away is when you're using cardboard and Excel spreadsheets and PowerPoints and duct tape on the floor, we're using tools to create a visual, but it's very hard for everyone to be on the same page. So if I'm the operator and I'm the shop manager and I'm the engineer and I'm the CEO and we're all standing out there looking at these lines drawn on the concrete, do you think we're all talking about the same thing and we all visualize it the same way? Experience tells me probably not. Because the CEO is thinking about how much it's going to cost him. The operator is thinking about how cool this is going to be to finally have what I want to have. The engineer and the plant manager are like, I'm just stuck in the middle. I got to make something work. And then the janitor's like, where are you people putting it there? Now we can't clean it, right? But the space is the space, but we can't visualize it. We can't simulate it. We can't do anything with it. So then a lot of people move to the point of, okay, well, we'll do 2D CAD. 2D CAD inherently is static. So you have the same challenge visualizing that to people. So when we talk about factory flow and factory simulation, what we're talking about is putting the science behind the objects. And in this instance here, we can bring the 2D to life. We can put in the takt times that take place, and then we can create an outcome to where people can see where that forklift is going, where the path is going to be, what the bottleneck is going to include. So if you have 2D today, as an example, you can use that in tools like Factory Flow to bring it to life and do what if scenarios and get everyone on the same page. Because the biggest challenge that happens is usually an engineer, and I'm a manufacturing engineer by, dinosaur schooling back in the olden days. But we would go out with clipboards and stopwatches and we would take all that and then we'd put in an Excel spreadsheet and then we'd have our 2D CAD. And then we would, as the experts, we would try to articulate this and nobody could really visualize what we're talking about. And ultimately, to do any project, you have to get approval for the budget that's spent. So being able to show these things allows us to bring that information to life, and all of the information that we would normally track in Excel spreadsheets and 2D CAD and whatever drives we're going to put it on, I can put it in one environment and then do what if. Now, on top of that one show okay, Dean?
Yes, that's perfect.
Okay. So on top of that, we can also go to the point of adding a little more information. So I think this is the one I want. Same layout. Now we have forklifts going on a different path and they're loading and unloading objects, right? One's going to the dock to unload on the truck. The other one's taking it from the equipment in the other room, going through the doors, dropping it off. But one of the other benefits that happens with simulation is we have the ability to drop in mannequins that are predefined in the software. And from that, we can now start doing things like, how far does a human travel? Are they going to be in a position where there's a problem? We can start overlaying 2D and 3D together. We can also take it the next step up beyond this long-term, because again, the value of a platform is reusing the data over and over and over. We can start doing ergonomic studies. Is Dean going to hurt his back because I have him bending over 50 times a day to pick something up off the floor versus putting in a stand next to him that's mobile? The other one that comes into play when you start talking humanoids and mannequins is, what if I have one person handling multiple machines? Can I come in and do a what if scenario to see if those people could keep up? Because we all know that, if you have different shifts of workers, you have different rates at which people work, and you have to account for that. So if we're talking about machines running and people tending them, what does that path and process look like? And again, this is all just done with 2D layouts and 2D images. Now, for us, whether it's 2D or 3D or point cloud, we don't really care. Input objects are input objects. So if we were to take like the next step and see what it would look like with a little more 3D. Let's say you've used some 3D CAD tools to do layouts, what if, try to get that Z height in there. We have the ability to bring those in just like a 2D file and then do what if scenarios. So in this instance, it's a simulation of assembly. We're assembling XYZ product. And then based on that, we're determining, one, how many people do we need? And number two, is there a bottleneck if the second person works faster than the third person? And how many things can we get out of that in a given day? We can also do what if scenarios. So let's say, every fifth one, the part gets scrapped. Well, we could create a workflow to handle every fifth one to determine, are we putting the scrap in the right spot? Are we going too far? We had a customer, as an example, build a brand new facility and build a brand new extension to their facility. And when they built the new extension, they didn't put in a bathroom. Doesn't seem like a big deal, but running an analysis on how much time was lost in production every day for an employee to use the restroom twice a day, they would waste about 45 minutes of time by the person stopped their job, walked all the way across the plant, used the restroom, walked all the way back, got their machine started up again, and then continued to run. So little things in like planning and what if scenarios you can play out in that by having the humanoids or the mannequins interact with your 2D geometry or 3D geometry. Another type of flow can be something as simple as taking material to and from a given machine tending as an example. A lot of companies want to get ahead. And so they go talk to their machine tool dealer, their manufacturer, and they're like, oh, we can make you 20% more efficient if you swap out your old machine for a new one. And most people are sold, let's do it. And they bring it in, it's 20% more efficient with the assumption that you can get material to and from that machine 20% faster than you used to. So one of the big things that happens in factory flow and plant layout is I get hooked into buying a new machine, but I don't think about what that layout looks like going to and from. And so I never reach my efficiency potential because I didn't account for how much more material it's going to take to feed that machine and having enough storage for that machine to be able to produce goods that can be shipped out. In a mill with a robot tending, okay, maybe it's pretty simple. But if I go from like a single spindle lathe to a index machine with 64 axis, you're talking a big difference in productivity and output that you have to account for. And most of the time you have to have some simulation or validation to be able to account for that over an 8-hour shift or over 3 shifts or over 40 hours or over 60 hours, because bottlenecks don't always show up in the first 10 minutes of running. Sometimes it's a slow build to see where that bottleneck happens. Another example of flow, bear with me here just a second. I'm going to move the chat window out. No, wrong one. Told you it's my second day around a computer. So another example of fluid flow is something that I used to do 10 years ago, which is recycling, sorting, conveyors running together. So in this instance, we're using simulation to validate the flow and processing of multiple different materials into their different bins and storage, and then also determining at what rate we can empty those bins after it's been sorted, run them through the baler, and then change material in the baler to figure out what our output's going to be on that side. Oftentimes this is calculated in tons per hour. So 20 ton per hour system, 40 ton per hour system. But you'll notice here also one of the benefits of factory flow and plant layout and all of those things with a unified platform is you can have fully detailed models and layouts if you want. So if you look at the upper left-hand corner, that is the actual production models that are being used. So being able to handle larger assemblies and things like that, that is a big advantage here. We don't have to dumb it down to just basic rectangles and steps. The last one I'll show before we jump into robotics here, I want to make sure I stay somewhat on time. I could talk for days about this if you can't tell. They just usually let me ramble for no reason. But if we're talking about where do you start, right? Most people start on one small project. They don't look at the whole plan or the whole big piece all at once. Generally, there's always a starting point, right? It's like when you get in your car, there's a starting point, how you leave your driveway. You can go through and start creating individual cells here. So this one's doing a track mechanism. We're pulling things out of inventory. A couple people are assembling it. If you're using AGVs, AMRs, forklifts, overhead cranes, it's all calculated the same. But as you grow over time, you can take the smaller projects that you worked on and continue to build them up into the bigger factory. And you can reuse that data to run it over and over and over again. So if you wanted to figure out and refine all the small cells on the side, you can do that first and then leverage those in the larger one to ensure that there's not a bottleneck that happens between them. So are we supplying parts fast enough to the main cell? So in this instance, this is a good example of building and growing as you grow through your digital transformation. Multiple things here being ran in simulation, but most of the sub-assemblies, if you will, if we're talking CAD terms, are being calculated on their own, and then the sum of that is being put in the larger system. And the last one I'll show on this before we talk a little bit about robotics is if you don't have 2D CAD or you don't have 3D CAD, one of the things that is a possibility is the ability to bring in scan data. So this is one of our customers, their case study on the SolidWorks website. They went through and they scanned 900,000 square feet. And then from there, they can bring in the scan data and then remove things, add things, use 2D CAD, use 3D CAD, but they can capture the steady state of where their facility is today, make modifications and changes for the future. And one of the things that comes into play with Point Cloud is we can then break those subsections out. So a fair number of their machines were built post-World War II. So in that instance, they don't have drawings and prints. They were just built out of necessity to, move their business forward. So inside of factory simulation, we have the ability to take that point cloud, break it up into sections, and then treat it as parts or subassemblies and move them around, reorganize them, put them in new facilities, whatever you really want to do with them. So here you can see they're taking an old beam line and then they're making adjustments to it and they're moving it to new areas in their factory, because part of what they want to do long-term is completely reorganize their factory for continuous improvement in Industry 4.0. They have 3 different product lines that run through this facility that run like their own business. And what they want to do is streamline that process to be as efficient as possible to reduce the number of steps that material takes as it moves through the factory. So completely rethinking what they do to be, competitive for the next 70 years like they have for the last 70. So in here, you have the ability to go through and break out those points. I'll show a couple examples of robotics, because most of the time, once I create my factory and I optimize it, then the next step is I want to go through and create automation. So if we're talking about automation, one of the things that comes into play, which is sort of a popular thing these days, is machine tending. So we have a library of robots and translators, most of the major brands for industrial and cobots. And from there, we can drop those in and then start programming those robots. And what makes it unique for what we do is if you had a robot or a cobot already set up, we can upload that program, simulate it, validate it, modify it, and send it back out. So you don't have to start virtually to do the real. We can take what you have in the real and apply it to virtual and make changes. Likewise, because this is one platform, the part that you see being tended here is actually one that we ran a couple of years ago at 3D Experience World live. So this cell and machining was all programmed in the same environment for the CNC machine that we're now using to program the robot here. The value of a platform is all the data is the same. So the CNC programmer is using this piece, the robot programmer is using this piece, and we're doing the same thing, all working on the same data. One of the things that comes into play, let me find the one I looked for, is we can have multiple robots being programmed and work on multiple things at the same time, and they can be multiple different brands. One of the other benefits that comes into play with offline robot programming is, let's say this was a an orange robot and it's getting older and I want to look around and maybe I want to replace it with a yellow robot. We can take the program from the orange robot, upload it to the platform, swap from an orange to a yellow, rerun the simulation, validate that it's going to work from a motion and movement, send it back out in the native yellow robot program, and continue to run. So we can use the translator for verification and validation of, will it fit, will it move, will it handle? But also, if I were to buy a new model or a different brand, will it fit? Does it work? And if it does, can I just send the new updated program out in the language that the yellow robot needs? The answer to that is yes. That's one of the benefits of offline programming. So being able to do all those what if scenarios here without taking anything offline or getting in harm's way because robots can be dangerous, we're able to validate all that stuff without cutting into our production. And we're also able to make a better decision the first time. Another area that comes into play is we have the ability to use physics in our simulation, to where this was a customer example for one of their family nights. They programmed the robot to throw the basketball. And then in here, we can use our physics engine for robotics to be able to see how that ball is going to work and how it's going to interact. So if you wanted to see how it's actually going to move and bounce when you're doing the program, to see if your acceleration, deceleration is in good enough spot, we can do physics to determine that. Likewise, physics comes into play in robotics because conveyors can also be robots because it's PLCs and controls. We can use that same physics engine to determine how boxes are actually going to flow. So in flow simulation, I can tell you how many packages per hour I'm going to get. That is, something we can validate and simulate. I can then use robotics with the physics engine to determine, are the boxes going to travel where I want them to travel? And is there a risk of the boxes being damaged? So here you can see on that slide on the end, the boxes bounce. Maybe that's okay. Maybe it's not okay. Maybe I need to change that angle. But the key here is I can use one app for throughput, and I can use another app on the same data to be able to figure out how it's going to flow and if there's any gotchas that I have at the end. So that is really the power of using that unified platform. And then from there, if you wanted to do more system stuff with AMRs or AGVs or things like that, you have the ability with extended capability beyond robot programming to be able to connect and talk to PLCs also. We can validate the virtual to real or real to virtual by connecting the software to PLC logic and communication. We are PLC agnostic. So if you're using, Allen Bradley or Siemens or whatever, we can bring that in and then we can simulate and validate. We can also check to see what would happen if the line gets shut down. What's the restart process look like? Those are all things that can be done in a more advanced component. This is obviously a pretty advanced factory here, everything running on AMRs or AGVs. And then here you can see there from that little pop-up that showed up is you can validate the PLC logic of startup and stop. So just another example of if you get a little bit higher once the virtual twin is created. The other thing that comes into play too, just one last note, like I said, I could talk for days on this, is robots don't have to be orange, yellow, or blue, or gray, or whatever they're going to be. A robot could be custom-made machinery that moves in XYZ ABC. We can use robot programmer and simulation to validate a process on custom equipment that's being made. And unlike some of the motion study tools where you're just simulating the motion, here we're treating the gantries as robots. So they're moving XYZ ABC. They have acceleration, deceleration. It is more than just a pretty picture of how it's actually being ran. It's showing the actual process. And if I wanted to, output those moves, I can now take the moves that are in here, output it into something that's PLC, and use that as validation and verification.
Yeah, thanks, Mike. That was a great overview of some of the capabilities that we have with Delmia Solutions. It's just impressive that we can pretty much use any data that's out there, whether it's 2D, 3D scan data, and build intelligence and to make better decisions as you're either redoing a factory, implementing, new technologies, or, building a new one. Again, We appreciate the time everybody took to, sit in on the webinar. Again, if you have questions or you need, assistance with anything, please reach out.
Thank you, everybody.